Turbo Conquering Mega Eagle. Alright folks, how you doing? Okay, so I've got my my Chinese wind turbine apart, 800 watt Chinese wind turbine. I paid 130 quid for this, yeah. I was going to do a little video on modifying it, and I will still do that. This video, however, is more out of my surprise at seeing just how poor quality everything was inside of it. I thought I'd better do a little buyer beware video. I'll also state before I get going on this that I'm very aware that there's a big difference in quality between similar looking products coming from China. So this was the cheapest one I could find on eBay, and it was sent straight from China with free postage at 130 quid. Yeah, so I wasn't expecting the cream of the crop, if you like, but I'm sure they're capable of producing better quality products. I know they are. I've seen massive differences, and but I'm always nervous because the only way I'd be confident in getting the better end of the scale is if I was buying from an importer, perhaps, who did regular internal inspections on the products. Otherwise you don't know what you're getting. You might pay twice as much for exactly the same low grade product. Either way, okay. So the reason I pulled my turbine apart it was because it was developing very noisy bearings. So the yaw bearing, this is the post that attaches to the mast, and this is the yaw bearing. So this stays still, and the turbine housing pivots on this big bearing, and that was incredibly noisy. It's every time the wind changed direction, and we can actually see a bit of corrosion sitting on the inner race of the bearing there. Yeah, and I don't know why the outside hasn't corroded, and this is the inside. So I should imagine that's the result of the condensation in the housing dripping down onto this surface here. It's not noisy now because it hasn't got any load in it, I suppose, but it is rough. I can feel it's rougher than it should be. But and this is after 8 months, yeah. So 8 months of operation, and I've already got problems with the bearings. The bearing in the nose of it, this. Whoa! Watch what you're doing, Jimbo. There we go. There are powerful old magnets in there. Let's move that out of the way. That's the rotor, yeah. And that rotor is supported by this bearing in the what would you call that? It's the stator housing. It's also the front of the turbine. Yeah. So this bearing supports the sails and the rotor. So you can picture it. This rotor passes through this bearing, and the turbine blades bolt on the front here with one single nut. Okay, so this is getting very noisy because I got my turbine bolted to a container. The container sort of acts like a sound box, yeah. So any noise being produced by the turbine is transmitted down the mast into the container. So it was always a little bit noisy, but the noise levels just under normal operation were getting to a ridiculous point. I mean, I'd struggle to have made this video in the container with the amount of noise it was making. Row, 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 and it's a definite bearing noise. I couldn't feel any real major roughness in this, but there's getting to be quite a lot of slop in it, and because it's exposed to the elements, I suppose if you've got a sloppy bearing with a seal on it, it's only a matter of time before that seal goes bad and it starts letting moisture into the bearings. We'll go over the bearings a little bit more in a minute, just after I cover briefly the other things that I've noticed. So pulling it down off the mast, the first thing I noticed was the cracking in this O-ring or gasket or whatever you want to call it, that seals the whole body off from the elements. It protects the electrical components inside. So let's get a close up of that, see if you can see the cracking on that. Hang on, let me try and get you focused a bit better. You can just see the cracking on that O-ring. Now that is just on the outside at the moment, and there was no evidence of anything more than condensation being inside the housing of this wind turbine. So I'm pretty confident this was still doing its job at the moment, but it is not going to last much longer with perishing like that on the O-ring. So you know, I'm sure within another 8 months this would have been letting in all the weather. It's quite common with cheaper Chinese rubber. I think they throw a lot too much, you know, too much carbon black in there, and it's not that high a quality. It's generally speaking, from what I've seen of you know, the cheaper Chinese stuff, it's the rubbers and stuff like that go first. That's okay. We can find another O-ring for this quite easily, or make one and get something far superior in there that will last as long as I will. Okay, so then I pulled it apart, and the next thing I noticed was the windings on the motor. Now this is probably the most serious thing, and the hardest to rectify for someone. Going to be quite hard to show you this on camera, so we'll zoom in a bit. I'll try and keep my arms out of the way. Yeah, and it doesn't look tight from a distance there, does it? You can tell that it's not the tightest of windings, but if you look closely at it, I'll just lift the strays up with a screwdriver. It's been a really messy job with these windings. You know, there are rogue windings like this all over the place. Can you see that? Am I pointing that out as well as I can? I don't want to disturb them too much, obviously, because if I nick the insulation on them, then this thing will burn out and it'll be useless, won't it? But that's worrying. And the other observation I made with the not the motor, I want to say, keep on wanting to say motor. It is a motor. It's just a brushless DC motor. It was the laminations in the rotor and the stator. Now, come on. And they're starting to peel off, you know, on the back end here. There's bloody trains. Hang on a minute, I'll be back to you in a minute when this train's gone by. Yeah, so these laminated cores and stuff in motors or generators, whatever, or alternators, normally they're stacked and then basically held together with the edges are not peened over, but I suppose they're sort of pressed and dimpled, and that ties the whole lot together. But here you see they've just got random welds at various intervals. So there's a little glob of weld there. Delamination on this back plate again here, more delamination, random bit of weld, delamination, big snot of weld, you know. So this in itself isn't going to cause a failure, I don't think, but yeah, when you got tight laminations, that's the best way of achieving efficiency. If you've got loose laminations or gaps in between them, then you'll end up generating noise, like actual physical noise, not sort of radio noise. I'm sure you would produce radio noise with this, but and heat as well. So that's not great. And it's the same story on the laminations. in the stator as well. Yeah. So I don't know if you can make them out. Yeah, you can just see that back edge there. They're all lifting apart, aren't they? So I mean that's obviously been done when they force the windings through, and they've caught them just through a lack of care, I suppose. And that I'm going to struggle to do anything with. I'll just have to leave it, I suppose, and see what happens long term. The brush block. The brushes at the moment appear to be doing their job quite nicely. Brushes normally look for 70% contact area, and we've got 100% contact area over these brushes, so they're nice. The concern I have is in their installed position, there's they're sat like that, so these aren't really turning around very fast. It's not like the brushes on an alternator that I'm perhaps a bit more used to working with, but you know, they sit at about this sort of area when they're in the turbine, and there's a huge amount of movement there. Yeah, the quality of the brush block itself, it looks like it's the one of the first mouldings to have come out of the injection moulder in the morning. You know, so nothing's really heated up yet. And I'm pretty sure in a more diligent factory this would have been a reject, and perhaps it got rejected from the good pile, and they built the cheap ones for export to idiots like me out of the rejects pile. But you can see the flow lines in the plastic as the and it almost looks like it's burnt in areas, but it's not. It's just the fact that the moulding didn't come out too nicely. And it's a big heavy block, so that in itself isn't a problem. But again, what I found with brush blocks on alternators and electric motors is that the crevices and stuff, they either crack and then the electricity arcs across it, or the crevices fill up with the carbon from the brushes itself, and you end up with tracking going along, and it can cause a short or failure. And I don't think that's really going to be too big of an issue for me. Look, you can see those flow lines on the back a lot clearer here. But maybe this has got hot, and that's why it's bubbling up like that. I don't think so though. They just look like flow lines from a very bad injection moulding, to be honest. It's quite pretty actually. It's quite annoying as well. But again, this isn't a major problem for me, and I don't really think this is going to be a cause of failure. The sloppy brushes in the holder though, another train, that could potentially be a cause of failure. I mean, even with them pressed in all the way, and they never get pressed in this far in operation, there's still a lot of slop there. You don't want chattering brushes, do you? But yeah. But like I say, this isn't sort of high speed, so I think this will be alright, to be honest. Okay, what next? Cover the brushes, the brush block, the slip rings themselves. Oh, that unscrews. Would you Adam and Eve it? I hadn't even checked that yet. Oh, that would probably explain it. Oh, I'm a bit too close, you can't see me here. Let me back out again. Boop. Okay, alright, so this is the slip rings that are acted upon by those brushes and transmit the power down the mast to whatever you're doing with the electricity. That's nice. I hadn't actually messed around with that yet, but the only thing I noticed with these slip rings was the fact that I'll zoom back in. It hasn't been running concentrically, so you can see here we've got the worn area where the brush has been making contact, and a relatively small gap up here on this side, and then go to the other side and the gap's about twice the size. So this whole thing's been sitting on the piss on top of the mast, which isn't a huge problem, and like I say, it's turning at relatively low speed, so just just an anomaly, I suppose, and not one that's going to give us a lot of problems. But that's that. What else did I have to show you? Oh yeah, so those are all the major problems that I've outlined. Next, I suppose, are the couple of bits, the design issues. So they're all sort of workmanship problems. The only real design issue is the choice of bearing, and they've used double row deep groove ball bearings. So these are sort of a compromise. It's about the only way you can get a single unit groove ball bearing to take compound loads. Yeah, so ball bearings really are, in an ideal world, they'd only ever be used to take a radial load. Yeah, so if you can imagine this is a wheel running on a flat surface, that's applying a radial load to the bearing there, and then if I was to put a load in this direction towards the bearing, that would be what's known as a thrust load, and for which you get special thrust bearings. And then if we combine those loads, we get compound loading, and for that sort of work you need an annular bearing. That's the one. And quite often, look at old-fashioned cars and trailers and stuff, and they'll have a double taper bearing, so pointing in one direction on one side and the cone on the other direction on the other side, and that takes a compound load beautifully. It also takes radial loads nearly as well as a ball bearing, not quite as efficiently, but I think here we've mostly got well, I suppose we've really got a situation where it's mostly a thrust load, although technically speaking it's not, is it? Because we're not generating any thrust, but it's that's what the load would be known as in the world of bearings, I suppose. Hang on, I've been jabbering so much I've lost my train of thought here. Where were we at? So yeah, so basically ball bearings are never great, unless they're annular ball bearings with rather than just a groove for the balls to sit in. The groove is heavily shouldered on one side, and then you have two of them back to back, and that's generally what you find in the hubs of modern cars where they've got sealed bearings in the hubs. They're double row and annular bearings. Yeah. Okay. So, but they're quite expensive. I mean, they're very expensive. To buy a decent quality double or annular bearing the same sort of size as this is going to cost me about 20 quid. But that's where I'm going to go. I'm going to get myself some better bearings, and we'll try them. I'm going to find better quality gasket material or make my own gasket. I'm going to look for some compound. What I'd like to do is find something runny and sticky and pour it over the windings just to amalgamate the whole thing. I'm not so worried about electrical losses and that. Maybe it's not going to be quite as efficient, but at least it will last a bit longer. So bearing seal, some sort of potting compound for this. Brushes I'm not going to touch at the minute, and unless any of you can come up with some good ideas as to what I can do with these laminations, I'm not going to do anything with them either. But oh, cocking hell! Yeah, just put you out of the way somewhere. Go on, behave. What else? Yeah, I'll pull this one off as well, so to stop that squeaking. They're not numbered or anything, so I'm just going to have to select new bearings by measuring them, and I will put the bearing numbers up in the next video, when I've actually got them and made sure they fit. But again, this is only the 800 watt, and I should imagine, despite the 3000 watt unit looking very similar, it's probably going to have different bearings in it. So don't look at my video and assume that you've got the same bearing in yours. Okay, I think that's it. Right, just beware, folks. I've only messed around with wind turbines because I wanted to, basically, not because I depend on it, but for someone who's got a you know, a log cabin out in the wilderness and they want to you know, hike there and would like to have power when they get there to warm their tootsies up. I would suggest spending a lot more money than 130 quid on something that you're actually depending on. Yeah, you know what I'm on about. This is just a bit of fun for me, and I'm enjoying it. I always enjoy modifying these budget products. So that's where we're at, and you know, hopefully you've been warned a little bit and know what to expect and aren't too disappointed if your bearings start making noises 8 months down the road. Alright, so yeah, check out the next video on this and I'll try and modify it a bit. And until then, folks, take care and bye bye.